Students, this is the help video for 5.3 to 5.4 ALEKS, Unit 5 Study Guide. It says right here, this right triangle has side lengths of 5, 12, and 13. Use the lengths to find the tan, and that reads the tan, think of it as a tan ratio of angle B, and then the cosine ratio of angle B and the sine ratio of angle B. So angle B is the angle we're working with here. Therefore, that would make 12 the opposite, 5 the adjacent, and 13 our hypo. So the tan of B is TOA. So our opposite is going to be 12. That's our opposite. And our adjacent is going to be 5. And you're done. There's nothing else you do there. It just wants the ratio. The cosine of angle B is adjacent over hypo. So your adjacent is 5. And your hypo is 13. Again, you're done. The sine of angle B is OH, and your opposite is 12, and your hypo would be 13. Right triangle has side lengths. Now we're just doing this with variables, and we're finding the ratio of angle X. So from angle X, that would make E the opposite, F the adjacent, and D the hypo. So the tan of X would be OA. And our O is E, and our A is F. Ta-da! You're done. The sine ratio of X is O, which is OH. O is E, H is D. Cosine of X is and your adjacent would be F, and your hypo would be D. Take right here, we know that in triangle XYZ, angle X and angle Y are complementary, which means they have to add up to 90 degrees. And in this case, we're going to use variables here. The sine of X, sine would be opposite over hypo. So that would be X over the hypo Z. And the sine of Y, opposite would be Y over Z. The cosine of X is adjacent, and cosine would be Y over Z, and the cosine of Y would be adjacent, X over Z. So take a very close look here. That the sine of X is the same as cosine of Y, and the sine of Y is the same as cosine of X. So the sine of X equals cosine of Y. That's the red. And the cosine of X equals the sine of Y. That's the blue. So what it's saying is the cosine of one angle is going to be the sine of its complement. So if we do cosine 68, you take 68 away from 90. So the cosine of 68 would be the same as sine of 22 degrees. Taking a look here, from 39, this is your opposite, this is your hypo, this is for side, so this would be sine of 39 degrees equals x over 7, and you cross multiply, sine of 39 times 7 equals x, and you are done. Right here, we have overlapping triangles. We have a lighthouse, a ship, is 825 meters away. The angle of elevation to the base, we're going to pull these two triangles apart, is 37.2, and this is 825. And then to the top of the lighthouse is 38.3, this is 825, and it's asking, find the height of the lighthouse from the top of the cliff. So it's asking for this difference. So what that means is you take the red and you're going to subtract the green. The red is going to be x, and the green we will make y. And to solve for x, this is the opposite and adjacent. So we would do this. Watch, the tan of 38.3 over 1 equals x over 825. So that's going to be x equals the tan of 38.3 times 825, and the y is going to be tan of 37.2 over 1 equals y over 825. So y equals tan 37.2 times 825. So to solve for the height here, you would do this, okay? Bracket in your calculators, you would do in parentheses tan 36.38, excuse me, not 36, that's 38.3 times 825, and then you would do minus parentheses tan 37.2 parentheses times 825. And that would give you the height of the lighthouse. This one, we have the opposite and the adjacent. We want the angle, so this would be inverse tan, opposite over adjacent, gives us angle theta. Inverse tan, opposite here would be 17 over adjacent 10 would give you the angle theta, and it wants you to round to the 10th degree, which would be this first decimal place. This one, we have opposite and adjacent. Once again, this would be inverse tan, 105 over 159 would give you the angle theta. Alrighty, got another story problem. Don't be intimidated by these. You just have to figure out what's going on here. It says that Rachel sees 2 hot air balloons. She determines that the lower hot air balloon is 425 meters away and at a 31-degree angle from the vertical. So go like that. And the other one is 560 meters away at a 40-degree angle, and it's asking how far is this above greater than the left. So your question mark is this. So we have 2 triangles here. We're going to call this red one X. This is 31. And this is 425. And then we have the one on the right. And this is 43, and this is 560. And we're going to call this Y. Now, to get the yellow, the simple idea is this, is we take the blue segment Y, we're going to minus the red segment X. So the blue Y subtract the red X is going to get us the yellow. So look at what we have here. This is for X, that's going to be an A and an H. So it reads like this, cosine 31 over 1 equals X over 425. This would read cosine 43 over 1 equals Y over 560. We isolate, and this is going to equal X equals cosine 31 times 425. This would equal Y equals cosine 43 times 560. And we want the longer Y minus the shorter X will get us that height difference. So you can do all of this on ALEKS in one fell swoop, bracket. And you write parentheses, cosine 43, close the parentheses, 560, bracket, minus, bracket, cosine 31 times 425, bracket, and that will equal the height difference. Make sure you round to the nearest 10th place. This one is AH, looking for an angle inverse cosine 17 over 20 equals angle theta. This one, A over H, again, inverse cosine 6 over 14 equals angle theta.